Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about full subtractor. A full subtractor is a combinational circuit that has three inputs A, B and borrow in and two outputs D and B, which is difference and borrow. A is the minuend, B is the subtrahend and B in is the borrow produced by the previous stage. D is the difference output and B is the borrow output. So this is shown in the block diagram here where you have three inputs A, B and Bn and two outputs difference and borrow out. So this is the truth table of a full subtractor where you have three inputs A, B and borrow in. So you have eight combinations 000, 001, 010, 011, 100, 101, 110 and 111. And you have two outputs difference and borrow. So we know 0 minus 0 is 0. 0 minus 1 is you'll be having a borrow 1 and difference 1. 1 minus 0 is again you have a difference 1 and borrow will be 0 and 1 minus 1 is 0. So both difference and borrow is 0. So if we consider the first one here 0 minus 0 is 0 and again 0 minus 0 is 0. So both difference and borrow is 0. 0 minus 0 is 0 and 0 minus 1 is you have a borrow 1 and difference 1. 0 minus 1 is you have a borrow 1 and difference 1. Again, the difference 1 minus 0 will be giving a difference of 1. 0 minus 1 is having again a borrow of 1 and a difference of 1. And the difference 1 minus 1 will give again a difference of 0. 1 minus 0 is 1 and again 1 minus 0 is 1. So difference is 1 and you don't have a borrow here, so which is 0. 1 minus 0 is 1 and 1 minus 1 is 0. So you have both difference and borrow as 0. 1 minus 1 is 0 and 0 minus 0 is again 0. So both difference and borrow is 0. 1 minus 1 is 0 and 0 minus 1 again you have to borrow a 1. So you have a difference 1 and borrow 1 here. So from the truth table, you will be drawing the Karnaugh map and you will be simplifying it as shown here. So for difference, you will be having different ones which cannot be grouped here. So you're writing expressions for each one separately. And finally, when we simplify it, we'll be getting B in XOR with A, XOR with B as the expression. For borrow out, you're grouping it as three terms and the expression is A bar B in plus A bar B plus B B in. So for these two expressions, the logic diagram is drawn as shown here. So here the first one represents the A XOR with B XOR with B in. So you are using an XOR gate with the three inputs A, B and B in. And the second one is B, B in, A bar B in. So the three terms are first represented here using the AND gates, and for obtaining A bar we are using a NOT gate. Uh, so you are getting three outputs and all the three AND gates are combined together using an OR gate to get the final expression of borrow out. Some of the applications of full subtractor are it is used in arithmetic and logic units in computer CPUs, and full subtractors are extensively used to perform arithmetical operations like subtraction in electronic calculators and many other digital devices. Full subtractors are used in different microcontrollers for arithmetic subtraction. They are also used in timers and program counters and processors to compute addresses, tables, etc. Full subtractors are also used in digital signal processing and networking based systems. Some of the advantages of full subtractors are the designing of a subtractor is very simple as well as it's easy to implement, and the power deduction within the digital signal processing is also less. Computational tasks can be carried out at high speed. A disadvantage of full subtractor is that the speed of the subtractor is limited by the longest delay through the circuit. Let us take up some assessment questions. Full subtractor is used to perform the subtraction of the options are 2 bits, 3 bits, 4 bits and 8 bits. As the answer is 3 bits. The full subtractor can be implemented using the options are 2 XOR and an OR gates, 2 half subtractors and an OR gate, 2 multiplexers and an AND gate, 2 comparators and an AND gate. As the answer is 2 half subtractors and an OR gate. The next question is, what does minuend and subtrahend denotes in a subtractor? The options are their corresponding bits of input, its outputs, its inputs and borrow bits. Yes, the answer is the minuend and subtrahend represent the inputs. Thank you for watching this video.